Okay, today we'll be reviewing what ionic bonding is. So let's start off by going through what are some of the factors attributed to ionic bonding. First, they are held by electrostatic forces between the ions. Basically, this is talking about how the cation and the anion are kind of balancing each other out. It's in a lattice structure, which is basically like a crystalline structure, for example, like salt, like NaCl. It's most often between metals and nonmetals, and I know there's a typo, but it's let's say you have sodium and then chlorine, which makes NaCl, so metals and nonmetals. And then the electrons are not shared. Electrons will only be shared in covalent bonds, but in the ionic bonding, one atom gives up the electrons and becomes a positively charged ion, while the other atom accepts the electron and becomes a negatively charged ion. Basically, if you have Na plus and then Cl minus, the ion the atom on the sodium is given to the chlorine atom, which ends up making chlorine and octet. So now, ionic bonding also tries to look at the relationships between the distance and the charges, and that's basically summarized in the Coulomb's law. Basically, the Coulomb's law states that the magnitude of the negative charge times the magnitude of the positive charge divided by the distance squared. So the easiest way to explain this is to do some practice examples. Some of the questions they will ask you will be like, identify between NaCl and MgCl2, which one has a stronger ionic bond. The way you do this is look at the charges for each of the elements within the compound. Suppose for NaCl you will have, for NaCl you will have a positive magnitude for Na and a negative magnitude of 1 for Cl, which would equal 2. 1. And then for MgCl2, Mg will have a positive magnitude of 2, and then a Cl negative magnitude of 1, which would equal 2. So in this case, because when both of the charges or the product of the charges are different, you don't really have to consider the distance between the two ions. So in this case, MgCl2 would have the stronger ionic bond. The next example, MgO and CaO. And both of these have the same negative and positive charge products. So now you have to consider the distance between the charges. When you look at the periodic trends, it would state that Ca is a larger ion than MgO. Basically, in order to have a stronger ionic bond, you have to have both the cation and the anion as close as possible so that the nucleus has a stronger attractive force on the electrons. So basically a stronger effective nuclear charge. In this case, since MgO is smaller in terms of ion size than Ca, MgO would have the stronger ionic bond. Now when looking at zinc sulfide and MgO, magnesium oxide. In this case, it would be Zn always has a +2 charge, and MgO also has a +2 charge. And then sulfide and oxide ions both have a -2 charge. Since the product of the charges would equal 4 no matter what, you have to consider the ion sizes. In this case, MgO would have the stronger ionic bond because MgO would have the smaller ion compared to zinc. And finally, which compound has the lower solubility, NaCl or KCl? Lower solubility is attributed to the compound that has stronger ionic bonding. In this case, between NaCl and KCl, you would see that the sodium ion is a smaller ion compared to the potassium ion. So in this case, since Na is a smaller ion, there's a stronger effective nuclear charge between these two molecules. So the lower solubility will be attributed to NaCl.